So this presentation is about aqueous solutions and what is an aqueous solution and how do we measure aqueous solutions. So one of the things we have to understand is that in an aqueous solution, it's usually typically dissolved in water. So there's two different parts of a solution itself. So one of the things that I want you to know is that pure water does not exist in nature because there's an ability to dissolve many substances. That's why San Diego water is so hard, is because water has the ability to take all the minerals that are found in the soils and all this other stuff, and it's able to dissolve. Well, water samples with dissolved substances are called aqueous solutions. So really when you're asking for a glass of water from a restaurant or something like that and they use ordinary tap water, you're actually asking for an aqueous solution. Now there's two parts to an aqueous solution. Okay? There's the solvent and the solute. The solvent is dissolving medium, meaning the water is the solvent. And then the solute are the particles that are in the solvent. When you put the two together, the solvent and the solute combine to form the solution. So we're going to watch a quick little video on the idea of what a solvent and solute and solution look like.
A solution may appear to be a single substance, but it is actually the result of the mixture of a solvent and one or more solutes. Here, the girl is dissolving salt into water to make the solution for a saltwater aquarium. In this example, salt is the solute and water is the solvent. Salt water is a homogeneous mixture containing sodium and chloride ions and water molecules uniformly distributed throughout the solution. This table shows examples of other combinations of solutes and solvents. In each case, the substance with greater volume is designated the solvent.
So again, the substance that has the greatest volume is considered the solvent. The other thing I want to point out is that it doesn't always have to be a solid put in with a liquid. It can, as you can see, gas and gas, gas and liquid, liquid and liquid, we could go on forever. Okay, but the idea is that it's a solution. It's two different substances that are physically combined. Now, there's this thing called solubility. Okay, so how do solvents actually break apart? Well, here's the thing. It all has to do with because water's in constant motion, so it actually hits the solid and breaks the bonds that hold the crystals together. The process is actually referred to as solvation. I didn't make up the word, I promise you. Not salvation, solvation. Now, there are certain compounds that are insoluble, and that's because their attractive forces between the atoms is greater than the ability of water to be able to break it apart. Okay, so to give an example of something that is an insoluble solid, that would be like sand. Sand does not break apart into and does not dissolve, because if it did, we wouldn't have beaches. Okay, but it has a very strong bond. So solubility can be affected in a number of ways, and there are three different ways: stirring, temperature, and surface area. If we stir, we can actually increase the ability of it to dissolve. Same with temperature and same with surface area. So when stirring, what you're doing is you're actually bringing more solvent to the solute in order to allow for the faster dissolving. You've done this before probably if you've mixed sugar into water or anything else that you've mixed into some other substance. Temperature. When you increase the temperature, that means the water molecules are moving faster, and if they're moving faster, it will allow the solute to dissolve faster. Give an example: if you were to mix sugar into hot tea as opposed to sugar into cold tea, you would see that the hot tea would dissolve the sugar much, much faster. And then finally, surface area. So the smaller the crystals, the faster the crystals will dissolve because of the increased surface area. Meaning, like if you had block ice versus crushed ice will cool the drink faster, but it will dissolve much faster. Block ice will take much longer because it's less surface area that it has exposed. Let's talk about solubility here.
The more opportunities a molecule of solvent has to come in contact with a solute, the faster the solute will dissolve. If the solute is broken down into small chunks, it has a greater surface area and dissolves more readily. In both cases, however, the dissolved first layer has to drift away before the next layer can dissolve. Stirring, shaking, or otherwise agitating the solution further speeds up the dissolving process, sweeping away the dissolved layer and exposing more solute to the solvent. Increasing the temperature increases the speed of the molecules. The faster they move, the faster the solute dissolves. For example, sugar added to hot tea dissolves almost immediately, while sugar in iced tea normally needs a lot of stirring.
So there you go, the three different ways in which you can increase the ability to dissolve substances. So the amount of substance that dissolves actually is temperature dependent, okay? And if it's temperature dependent, that means that what you need is a certain amount of solute and a particular temperature in order to determine the solubility of the substance itself. Now, this leads me to electrolytes. Now, electrolytes are quite interesting little things. You've probably heard about it in Gatorade, that, Gatorade replenishes your electrolytes. But what really is an electrolyte? Well, an electrolyte is a substance that will have the ability to conduct electricity in aqueous solution. Weak electrolytes are covalent compounds, and strong electrolytes are ionic compounds. Okay? So ionic compounds such as sodium chloride is a very strong electrolyte. And a weak electrolyte is something such as sugar. It basically doesn't conduct a charge at all. And the reason that it's not is because it doesn't have any ions, so the electrons can't flow through it. So let's talk about concentration. What is concentration of a solution? Now, you've all probably heard of concentrate. Okay, thinking really hard? No. And what we're really talking about is the idea of concentration in the sense of how much stuff is dissolved in the solvent. And so we can qualitatively or quantitatively express these terms. So if we're qualitatively expressing it, we can call the solution dilute or concentrated. Dilute meaning that there's very few particles per solvent, or concentrated, there's a lot of solute per solvent. For